So here I have a balloon filled with hydrogen. It has a lot of chemical energy as hydrogen gas, and when mixed with oxygen, it's a very potent fuel. By igniting the balloon, I add energy and I set off a reaction between the hydrogen and oxygen that releases a lot of energy in the form of heat. The conservation of energy is one of the fundamental principles of our universe. Simply put, it says that in a closed system, energy cannot be created or destroyed, it can only be transformed from one form to another. The first law of thermodynamics takes this idea and modifies it for thermodynamic systems. It relates the internal energy of a system to the amount of heat added to the system and the amount of work done by the system. If we look at the explosion again with a thermal camera, you can see quite clearly how hot the explosion was. But the total amount of energy in the room is the same as before I blew up the balloon. It's just changed from chemical energy in the bonds to heat energy. Historically, this idea of turning heat into useful work was the main driver behind the formulation of this law. At the beginning of the Industrial Revolution, both scientists and engineers were creating steam engines in the hope that they could harness energy to further society and industry. The advantage was that they could automate some jobs and match, if not exceed, the power of the human labor force. Steam engines are based on the idea of heating water under pressure until it becomes steam. As it's heated, it expands and pushes a piston that produces mechanical work, be it moving a train or pumping liquids or any number of other functions. Blowing up hydrogen balloons is fun, but the conversion of chemical energy to heat isn't particularly useful. But what we could do is put it to good use in something like a rocket. In physics, work is done when a force is applied to an object and that object then moves a distance. One of the simplest ways of making this hydrogen do work for me is to build a rocket. The hydrogen and oxygen fuel mixture is exactly the same as with the balloon, but whereas the balloon expanded outwards in all directions with the explosion, the rigid walls of the Pringles can funnels the energy in one direction. The chemical energy is then converted into heat and kinetic energy, and by moving the rocket forward, useful work is performed. Rockets are useful if you want to send someone into space, but if I want to use my hydrogen for a more terrestrial use, then I'm going to have to harness the energy in a different way, or transform it to a more useful form. What I've done here is attach my rockets to a wheel, and when it spins, it's doing work as the rockets move around. Now what I can do is attach a dynamo here, which when the wheel spins will convert this kinetic energy into electrical energy, which I can then store for later use. The problem with this is that all throughout this process, you're losing energy in the form of heat to the room, rather than using it to do useful work. Because of this, it's actually a rather inefficient system. While no energy is destroyed, because it can't be, too much of it is lost into the room as heat energy. This issue isn't one that's just isolated to my rocket contraptions, but the issue of efficiency, which is trying to get more useful work out of the same energy input while battling energy loss, is one that's as important today as it was during the Industrial Revolution.